Student, in the previous class we discussed up to the concept of direction cosine of a vector, and there we see that the sum of square of direction cosine of a vector is equal to 1. Today we start with the concept of displacement vector. Okay, so what do you mean by displacement vector? So here I consider a three-dimensional coordinate system on which I take 2 points having the coordinate x1, y1, z1 and x2, y2, z2. Okay, the position vector of this coordinate x1, y1, z1 is r1 vector is equal x1 of I cap plus y1 of j cap plus z1 of k cap. And the position vector of this point x2, y2, z2 is x2 of I cap plus y2 of j cap plus z2 of k cap. Okay, so now if here we want to determine the displacement vector, so according to this diagram here del r is the displacement vector which is directed from the point x1, y1, z1 to the point x2, y2, z2. So if we apply the triangle law for this triangle, then the displacement vector del r vector is equal r2 vector minus r1 vector. So r2 vector is this, r1 vector is this. Whenever you take this subtraction, it gives x2 minus x1 of I cap plus y2 minus y1 of j cap plus z2 minus z1 of k cap. So this is the displacement vector between the 2 points having the coordinate x1, y1, z1 and x2, y2, z2. So if you want to determine the magnitude of this displacement vector, then according to our magnitude formula, the magnitude of the displacement vector is equal root over of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay, so now after this displacement vector, we have to know the very important concept of vector, which is vector product. Okay, so now there are two types of vector product. Number one, scalar product or dot product. Number two, vector product or cross product. Today we discuss with the scalar product or dot product. Okay, listen to me very carefully. I consider here two vectors. This is vector A and this is vector B. Theta is the angle between these two vectors. So then the dot product of these two vectors A and B is defined as A vector dot B vector equal AB cos theta. AB cos theta. See the right side of this definition. Right side gives the multiplication of magnitude of A, magnitude of B and the cos value of the angle between the two vector A and B. So therefore right hand side is a pure number which is scalar actually. That's why the dot product another name is the scalar product. Clear? So now this dot product have some important properties. You have to know all these properties. Okay, so now properties of dot product. Clear? Number one, dot product is commutative. Commutative means A dot B equal B dot A. Means the result of A dot B and the B dot A are equal. So means during the dot product, the position of the two vectors may interchange and that property is called the commutative property. Next, dot product is distributive. See the statement A vector dot within bracket B plus C equal A dot B plus A dot C. A dot is distributed with B vector and C vector and the result of LHS and the result of RHS are equal. That's why we can say the dot product is distributive. Number 3, whenever you perform the dot product of two parallel vectors, whenever the two vectors are parallel, the angle between them we know that 0 degree. So then from the definition of dot product, A dot B equal AB cos 0, and we know that cos 0 degree 1, so that's why A dot B equal AB. Clear? Next, this is very important. Numerical is asked on this concept. If the dot product of two vector is 0, then they are perpendicular to each other. Okay, this is a proof of this statement. What I say? Dot product of two vector A dot B equal AB cos theta. What value? The dot product is 0. So whenever dot product is 0, so from here we can write cos theta equal 0 by AB means 0. For what value cos is 0? That is cos 90 degree. So cos theta equal cos 90 means theta equal 90 degree. Means the angle between these two vector is 90 degree, means they are mutually perpendicular. Clear? Next, the dot product of two same vector. Here A vector dot A vector. So according to the definition, magnitude of A into magnitude of A into cos of the angle between them. Remember, among the same vector, the angle is considered as 0 degree. So therefore A cos 0 1, that's why A square. So therefore dot product of two same vector is equal to the square of the magnitude of that vector. Next, we have to know the dot product of the unit vector which is situated along x-axis, y-axis and z-axis. So that's why I cap dot I cap. According to the definition, I cap dot I cap means mod of I cap into mod of I cap. And I said previously, among the same vector angle is 0 degree, that's why cos 0. So this is a unit vector and magnitude of the unit vector we know that is 1. So 1 into 1 into 1, that is 1. So therefore we can say dot product among the same unit vector always 1. Similarly j dot j equal k dot k equal 1. Now we see the dot product among the two perpendicular unit vector like I vector I cap dot j cap equal mod of I cap mod of j cap. What is the angle between I cap and j cap? 90 degree, that's why cos 90, and cos 90 is 0, that's why I dot j is equal 0. Similarly j dot k or k dot I is equal 0. So therefore dot product among the two perpendicular unit vector is always 0. These two things you have to remember whenever you want to perform the dot product of two given vector. Yes, in the next point we want to determine the dot product of these two given vector, where a vector is given x of I cap, ay j cap plus az k cap. Similarly b vector equal bx I cap plus by j cap plus bz k cap. Now you want to determine the dot product of these two, that is a vector dot b vector equal ax I cap plus ay j cap plus az k cap dot bx I cap plus by j cap plus bz k cap. Okay, so now whenever you perform the dot product here, you have to dot this portion with this whole. Similarly, this portion with this whole. Similarly, this portion with this whole. But one thing remember, whenever you do the dot product of I cap with I cap, it gives 1. But the dot product of I cap with j cap is 0. Dot product of I cap with k cap is also 0. That's why whenever you perform the dot product with this whole, so it will gives only ax bx. Clear? Plus similarly, whenever you perform the dot product of this j cap with this whole, only j cap is 1, other two dot product are 0. That's why it gives ay by. Similarly, whenever you perform the dot product of k cap with this whole, k dot I 0, k dot j 0, only k dot k is 1. That's why plus az into bz. So this is the formula you have to remember whenever you perform the dot product of two given vectors. Okay, so now there are important application for the dot product you have to know. What are the important applications? Number one, you can determine the angle between the two vectors using the dot product concept. Clear? For example, you people consider theta be the angle between A vector and B vector. There are two vectors, A vector and B vector. The angle between them is theta. So you want to determine the value of this theta. So what is the process? From the definition of dot product, we can write A vector dot B vector equal AB cos theta. And from here, cos theta equal A vector dot B vector by AB, where A be the mod of A and B be the mod of B vector. So therefore cos theta equal, as we know, A dot B is this, that is AX BX plus AY BY plus AZ BZ, and this is mod of A, and mod of A we know from the formula root over of AX square plus AY square plus AZ square into mod of B means root over of bx square plus by square plus bz square. By this formula, we can determine the angle between the two given vector. Another applications is there. What? We can find out the projection of a vector along another vector. How? Just see the diagram. This is the b vector and this is the a vector. A vector makes an angle theta with b vector. And student, you are want to determine the projection of this A on B. To determine the projection of A on B, you have to take the component of A along B. What is the component of A along B? That is A cos theta. So therefore, A cos theta is the projection of the vector A along B. And this A cos theta value we can determine from the dot product among these two vectors. Now see here, therefore projection of A vector along B vector equal A cos theta equal from dot product A vector dot B vector by mod of B. Okay, and again we know B vector by mod of B means B cap. So that's why A vector dot B cap. So this is the formula by which we can determine the projection of vector A along B vector. Similarly, if anyone want to determine the projection of B along A vector, then the same process, B cos theta, A dot B vector by mod of A vector. And A vector by mod of A means A cap, so that leads to B vector dot A cap. So by this process, we can determine the projection of a given vector along another vectors. This dot product in our daily life have some applications. Okay, where we can use the dot product in the calculation of work done. Remember, work done is the dot product of force vector and displacement vector. Similarly, we can determine the power. What is power? Power is the dot product of force vector and velocity vector. As work and power are the dot product of two vector quantity, and dot product always gives a scalar. That's why we can say work and power both are scalar quantity. Okay, so this is the all theory about your dot product. You have to remember to solve the numerical problem. From this portion, no theoretical question is asked, only asked the numerical type questions. I will provide you the numerical type questions on this particular topic. Thank you, students.